All right, guys, welcome back to another KevCAM night class tonight. Tonight have Steve Welsh helping out with any questions or concerns that come up along the way for you guys. Steve, are you with us?
I am. Evening, everyone. Thanks for the attendance, and looking forward to showing you some advanced mill turn tonight.
Absolutely, guys. And sorry, I'm just trying to drag out my question panel here. And Ben, it's great to have you. And everybody else that's joining us tonight. And I do see a couple new names in here, so I'll go over the usual. For everybody that is new tonight, the night classes are solely dedicated for training purposes for you guys. So you guys tell me what you want to learn, and I will teach it for you, or attempt to teach it for you, at least. But no, for those of you guys that we use GoToMeeting, and for those of you guys that are new, everybody is in mute just to eliminate any background noise. And if you guys do have a question, there is a question panel. I took a screenshot for you guys right here. If you hit that little arrow out, and it will expand it down, and then you guys can type in your question there, and Steve will interrupt me and tell me to answer the, or read me the question. I'll answer you guys' question right on the spot.
There we go. Yep.
And like I said, these classes are completely laid back. There's no formality, so feel free to ask any questions at any time for you guys, and we'll get those answers or those questions answered for you guys. And like I said, these classes are for you guys, so if you guys do have a idea or a suggestion that you would like to see in the night class, shoot those over to me via email, and we'll definitely add those in there for you guys, so we can help improve your guys' SolidCAM experience. So, and for anybody that doesn't have my email address, I just put it in the chat for you guys. And one last thing here is every night class is being recorded, so please come over to the SolidCAM University channel. Make sure you hit that subscribe button, because for those of you guys that know, I'm trying to beat Sydney in subscriptions. So definitely come here, check it out, hit that subscribe button, and we're constantly adding new videos throughout the week too. So we have the full night classes, and then there's some short videos that Mark or myself will put together for you guys too, on just some tips and tricks along the way. Mostly Mark and does a fantastic job on doing these quick little videos for you guys. So, all right. Oh, one last thing is, if any of you guys have a LinkedIn account, feel free to add me in on LinkedIn. You should see my ugly mug, the same one as on the YouTube channel there. Steve, don't say anything. And come
bit my tongue.
come add me to your LinkedIn, and we can connect up that way for you guys too. But like I said, the best way to get a hold of me is via email, or give me a call on the support line for you guys. All right. Oh, one other thing too is I get asked this question quite often, is where can I go, and this is more for the YouTube guys that are watching this at a later date, where can I go to sign up for your night classes? Well, if you guys come over to the SolidCAM, the main site right here, make sure your flag up here is set to the US flag. If it's set to any other flag, you won't see the night classes. So if you come over to the webinars and you come down and come to the KevCAM Night School, then it will pop up for you guys, and you guys will be able to register. So here's where you can kind of come check it out. We have a whole new lineup coming up. I'm just waiting for Jack to update it on the site. And like we talked about last week, we're actually getting Sydney in here, and he's going to show you guys a sneak peek of SolidCAM 2018 and all the cool new features that they're adding in there for you guys. So bring your questions and be prepared to ask away, because Sydney, he's been at the, how long has Sydney been with us? 14 years?
Ooh, I think, yeah, at least, Kevin.
Okay,
yep.
Somewhere around there. Old timer. But
yep.
Man of tons of knowledge, so definitely feel free to ask as many questions when he comes in next week. Okay, so let's get to an advanced mill turn part. So this is going to be a last of our mill turn series for you guys, and I tried to find the most complicated, scary looking mill turn part that I could think of for you guys. Unfortunately, I'm not going to be able to program this live, because this night class would be about 2 hours long to do this one, and Steve would be barking at me. So I'll keep it shortened down. But what I'm going to do is go through each and every operation and show you what geometry we picked, how we kind of went about this part, and all the different ways of kind of going about machining this part. Okay, so we'll start off with our first operation. Now this is done on an older machine right here, and I'm actually going to kind of do some switching around at the end, so to kind of go over the channel synchronization. So, but for this one right here, and this is more or less kind of a refresh of what we've done in the past. And looking at this part, it looks scary. I'm not going to lie. There's a lot going on here, but when we actually go through it, you guys will actually see how simple it is to actually program this part for you guys. So, okay, so we started off with, let me get my part rotate around here, with our balance roughing. So that's going to be your upper turret and our lower turret machining at the exact same time. The upper or the lower turret is going to be going a little bit behind the upper turret. So if I just show you my geometry, all I did is just chain my outer perimeter. I want to machine it up to where, let's call it the cam lobes are. Whoops, let me fit this here for you, get this back up on top. So going all the way through, all the way up to this cam lobe right here. And we got our main tool as tool number 5, which is in the spindle. We got our slave tool, which is our lower turret. Level same as usual. Technology, like I said, we're going to be trailing 5 millimeters behind and just doing a roughing strategy, leaving that 0.15 millimeters on there. So let's just do a simulate real quick. And we'll do a turning. Get this part kind of zoomed up for you guys.
Kev, just real simple to pick stock too. I mean, I'm thinking you started with a round piece of stock.
Yep, absolutely. Yeah, I kind of skipped over that part. And great point there, Steve. So we just started off with a simple round stock for starting off this part. So pulled off a bar of round stock that's a little bit larger than what we have. We can kind of see our round stock. And like I've said before, your blue area right here is your stock, and your orange is your actual SolidWorks model itself. Now, if we go into HostCAD, we can kind of see it too if we do the Solid Verify. And we can also go into, sorry, that was HostCAD with Solid Verify. And then we can also go over to Solid Verify, and we're going to see the exact same thing. So this stock is was defined kind of like what I've gone through in the past with the stock over here. Okay, so now, and I'm really sorry, guys. I don't have a machine setup or a machine sim for this particular part here. I would love to show it, but I was trying to get Florent to pass it over, but didn't have one quite ready for us. So what we're actually doing here now is we're going to move the upper turret out of the way. And we talked about this last week using the MCO. So what's happening is I want to move that upper turret out of the way so I can come in here and start roughing off using my lower turret. If I don't tell it to, for this specific machine, to go to the home position, it's that tool is just going to kind of hang down here, and I don't want that tool sitting in the way. So what the post team did is created a upper turret movement. So if I click on upper turret, I'm telling it to move, and it's going to move out of the way for us. Like I said, if you guys do need something like this, don't feel like you have to create this yourself. There's a lot in the MCO, and that's why I didn't cover it, just because it's really based off of the post processor more than anything. Is contact your post guy that's been working on your post, or for those of you guys that are here in the US, you don't know who your post guy is, contact Eric Middleby, and he will get you pointed in the correct direction for you guys to get that MCO set up for you. So don't feel like you guys have to create that on your own. We're here to hold your hand along the way for that portion of it. All right, so what I'm going to do is I'm going to be roughing off my face here. Now, as you guys will see, is I went through and renamed all this stuff. So some of this may not make a whole lot of sense to you, but now when I come back through it, it's easy for me to understand. So what I'm doing here is I'm roughing the face using the left spindle. This is something that I kind of always overlook, and it does come up every once in a while. And granted, we can come in here and I can hit the checkbox oops, hit the check box and kind of see what's going on. But to be able to kind of graze through this stuff without having to turn on all your tool paths is a little bit cumbersome. So if you guys do put this naming convention in here, it will definitely help you out. And you guys can do that by just hitting F2. If you click on the operation F2, and it will rename it, and you can type it in there, or in the actual operation itself, you can name it right up here. And as soon as you hit save and calculate, it will update for you guys. So, okay, I'm rambling on here.
No, it's a really good best practice, Kevin, you know.
Yeah. Okay, so now I just want to face off, kind of rough it out. So if I come in here, I just grab just that tiny smallest little line right there, and I just did the auto extend to stock using my lower turret here. Got my tool set up. Technologies, just doing a roughing strategy, leaving 0.11 millimeters on there and not doing any finish pass. So if we go ahead and simulate this here. And like I've said before, when you guys are doing turning, try to stay with the turning one here. I find it the easiest to use, and you can really see what's going on, especially since we have our stock showing there for you guys. So, okay, so you can see, roughed it out. If I kind of zoom in really far here, you can still see I have a little bit of material still on there. So I just kind of facing off the end of that part as a roughing strategy. Okay, so this one I'm going to rough out the front groove, and as soon as I calculate here, so right here is I want to groove out this, chunk it out, and just rough it out, and then I'll come back with a finishing tool here. So if I show you the geometry, you can kind of see the purple line right there, just coming in there and roughing this strategy out here. And like I've talked before, the green line that you guys are currently seeing is our updated stock. That's why when I change something up here with my rough face, a couple operations that are affected by that got out of sync. That's only because something changed, and that updated stock just needs to be updated. You guys can have this set up to be automatically done, so you wouldn't even see it. It would automatically do it. I like to see kind of what things change. Like I said, the machinists, we like our control.
On the fly, right, Kevin?
Yep. Absolutely. So we're just doing a standard roughing operation right here, leaving 0.12 millimeters on there. Like I said, no finishing. Let's go ahead and take a peek here. Zoomed in. Doing a zigzag pattern, and we're still got material. So if I zoom in, we'll be able to see we still have material going all the way around for us. And so what we'll do is we'll come back with a finishing insert and clean up the entire thing. Let me just calculate all these so we're not out of sync here. Calculate real quick. And then
Kevin, how do you decide when you go to a grooving tool versus, using descending motion? Is there any kind of, thought process there?
Anything deep, we can really hog out a lot with a grooving tool. Putting that straight down pressure in the y-axis, we can really get a lot of material removed out of there really quick. Okay. It's kind of like, the drilling versus using an end mill. Drilling is always faster to get material versus using an end mill, using a circular interpolation. Kind of the same strategy here. So I just want to get that bulk of the material out of there.
Anytime you're going deeper or have a lot of material.
Gotcha. Exactly. Exactly it. All right. So kind of little off subject here, but after doing that calculation, I have it set up in my settings so it automatically shows the tool bath. Instead of going through and having to uncheck all these, if you guys just click the operation checkbox right here, they'll all automatically uncheck for you. So, okay. So now we're going to be doing the relief cut after the threads, which is that surface right there. So in this thread relief that I have set up here is just doing simple single line going down. Go to our tool, and basically this is kind of getting the rest material out of there. So we got our grooving tool again, same tools we used in the previous operation. Technology, here's the mode I want to go to, tool side right, just doing a single step down, and I think, I can't remember, nope, I am finishing this one off. So I don't have anything put in my offset. So when I come back with that finishing tool, this will already be finished off. So if we just do a simulate real quick. And I apologize if I feel like I'm rushing through this here. Oh, no, I'm sorry. We're just cleaning up that backside is what's going on there. And the way our finishing tool is angled, it won't be able to hit that wall, and I'll show you that here. And like I said, I apologize for going through this a little fast, but there's a lot in here. Okay, so let's finish the outside diameter. So I'm just going to do a show here, and we're coming in here with our purple line. And this one actually has, we did point to point on a lot of this. So you can see my purple line goes straight across here, and we're going to kind of skip over, that valley right there. Another way of skipping over that valley is using that non-descending motion in the strategy. So we could turn that on too, so we won't have to worry about it. But since we were drawing in geometry, doing point to point to skip this in cut right here, figure just keep going along with the point to point. Okay, so this one, we should be roughing and finishing. So we are doing finishing only on this specific strategy here, and just doing a simple ISO turn. And I shouldn't have saved and calculated because it was already calculated.
All good.
Happy.
Hey, Kev,
yep.
Would this be a fair statement too? You kind of eyeball out the part and try to keep the tool, like that grooving tool. If you had multiple grooves, you'd want to pick those grooves, rather than bouncing between tools, right?
Yep. Try to keep your, it's all off of preference. Preferably, I would say try to stick with tools as long as you can. That way you're not getting that wasted time of tool change. For those of you guys that are doing prototype work, it really doesn't matter because cycle time really isn't as critical as a high production machine shop, I guess you would say.
Gotcha.
So,
yep.
And then you guys do have the option. You guys can sort these tools by tool number too. So you guys can right click on here and do sort by tool numbers. So it groups all your tool number 2s together, all your tool number 3s together, and so on. Just remember, after you do that, make sure you do a solid verify on that to make sure that tool isn't doing something where a previous tool needed to kind of rough it out and that tool is coming to finish it, kind of deal. So
perfect.
Okay, so we got outside diameter cleaned up now. Let's go ahead and thread our large threads right here. So if I do a modify geometry, just grabbing that straight line and going a little bit farther past here. And grab my threading insert here. And we are doing I should have looked this up real quick. 1.5, give me 1 second here. What is that? Just trying to find it. I think this is a M16. No. Sorry, guys, I'm trying to find it for you. M10 by 1.5, I think. I can't remember offhand. But so we're doing a metric thread. So we got our major diameter, minor diameter, our threads per inch. Not going to do a finishing pass, using the threading cycle that's in the machine here, stepping down with multiple step downs of 0.3 millimeters and a minimum step down of 10. So, sorry, I had to get a drink there. What that means is the max that we are going to go is that, 0.3 millimeter step down. But if you take that 0.3 millimeters and let's say it can't fit within the range because you're taking 30.3 millimeter step downs, but you have an additional 15 left over, that's where this minimum comes in, and it's going to automatically insert that extra 10 thou step in there to finish off those threads for you. So, okay, so let's take a peek at what we got here. And we got our threads in there. We got a little bit of material still right here, so we'll come back and get that finished out here. The threading insert is just a hair off of our model here, so that's why I was just showing just a hair off, but we got nice clean threads. And long as everything's good here, we are golden. Okay, so now what I'm going to do is I'm going to move my lower turret out of the way, which is going on right here. And this is just a simple MCO telling the turret to move out of the way. Now, what I'm going to be doing here is, let me minimize this for a second, is I'm going to be grooving out this area right here. So just coming in there, chunking out that material like Steve was talking about earlier here. So geometry. Just got this U shape. I'm going to zoom in here for you guys. I'm getting that material out. Using that grooving tool. Levels, we're going to be doing long external. Doing a roughing strategy, leaving that 0.15 millimeters, and doing a finishing pass, keeping that tool down only. So it's going to try to keep that tool down as much as possible. So it's going to play this. And like I said, this is pretty much, same thing as what we've been kind of going over for the last few weeks here. So like I said, a lot of this should be repeat for a lot of you guys. Hopefully I'm not boring you to death with this, but if you think about it, it's just a little bit of turning, a little bit of milling. Okay, so now I'm going to do the rest machining on that one. So just did save and copy on, no, I didn't do a save and copy, just created a new operation, did rest material, and by doing, sorry, let me get to the geometry here. Finishing off, get my part in here. These little areas where that finishing cutter couldn't get in. So you can see, trying to get zoomed in here for you guys. So you can see we got a little bit of material that's still left down in here, and that's where our stock is currently, and we want to machine it down to here. So we're kind of doing a rest material to get that out of there. Dang it, I forgot that save and calculate button. It's eating away at our precious time, Stevie.
No doubt.
All right, let's do turning. And do we have Ronnie in here? Ronnie, I did hear back from development on, Ronnie had a great idea. So as you guys are seeing, every time I come into turning, I have to click to zoom in that part. They got that new feature added in, so you guys don't have to constantly zoom in on that. It will stay where it was last positioned for you guys. Okay, so we got a grooving tool, and like I said, just finishing off that material. So you can see now this entire area is finished out. Pretty much everything is the size except for our angle grooves here, a little bit of our undercut over here, and that's it except for the backside. All right. So now I'm going to do this groove right here. All right, let's do a show. So just doing that little U shape right there. And we're actually using the angled groove operation for this one. Using, sorry, I forgot to tell you. So when I move that lower turret out of the way, we're switching back over to that upper turret now. Using kind of that same grooving tool and doing an angle on the external, doing a roughing strategy, keeping that 0.07 millimeters on there, and doing a ISO turn method to finish it off. Simulate here, turning, coming in there with that angle groover. And for those of you that haven't seen the rest of the night classes, you're not seeing the entire holder here. If you guys want to see that holder, this is a STL holder, and so to see it, we would have to go over to the Solid Verify side of things or the machine sim. And I'll pull up the Solid Verify real quick. And that way you guys can, whoops, hitting the wrong button here. So now we can kind of see the entire holder coming in there at an angle and doing our groove. And we're done. So what I did on that one is just did a save and copy. And now we're going to be doing the front side. So if we go to geometry, show that same U shape right there, easy peasy. Everything else is the exact same. Go ahead and simulate this real quick. And we got that out of there. And we can actually, can't remember, I did put a little bit of a chamfer lead in and lead out, and you can kind of see that round radius right here too for you. Okay, so now let's start roughing out this undercut area right here. So just using a standard turning operation, I'll show you the geometry here. Coming in here and just grabbing this material right here. And like I said, you can see that green line. That's pretty much all we have left there for this. Doing it. This is kind of like a button head or a, trying to get it in picture. Oh, dang. My space ball got a little fast on me here. So kind of like a button head cutter or lollipop cutter, or I'm not sure what you call this, but a rounded insert grooving tool, I guess you could say too. Have it kicked off at 45 degrees as an additional angle. So technically it is set to straight down, you can see right here, but then we kicked it off to a 45-degree angle here. Technology, just doing a long external here. If we go to roughing strategy, taking a couple steps, leaving that 0.1 millimeters for a finish pass. You can see we don't have any of our finishing strategies turned on here. And just kind of chiseling away at kind of roughing that out. So not too concerned about how everything's looking. I just want to get the majority of that material out of there. If we do a solid verify, you can kind of see a little bit better of what's going on. Play through. And pretty smooth for doing a roughing strategy, but you can still see we still have material there. All right. So now we're going to come in there and use a 5-axis, or well, I call it 5-axis, but simultaneous tilted turning. So we're using the same contour as what we did before, using just a little bit different of a tool coming at this. And so now we're coming in our clearance in the Z direction. We're working on tool side right. And tool axis control we're using through tilt lines and all lines weighted by distance. So if I show you my tilt lines, you can see I got some temporary lines that were just drawn in here. And it's gonna, the tilt lines are, and like I said, a little bit of repeat here, but the tilt lines are how do you want that tool to move through that entire cut. Just using no lead in or lead out, no gouge check, and the rest of this we don't even touch. So let's take a peek and see what's going on here. I think after this class, I think, Steve, I could get you to program this part for us.
Hey, man, the machine's worth too much money for me to crash it, man. No, you brought up another good point, though, Kevin.
Yeah.
I've been involved in software for a long time, and, you know, one thing we want to stress is we love to hear feedback. We can't promise that if you make a feature request, it's going to be in there, you know, the next release, but we love hearing from the user base about, hey, this would be really handy, because we don't know, we're using the software all the time, but we're not in production all the time. So if you have ideas, please, please, please get them to us, and, you know, we'll analyze it and do our best to get it into the software. So.
Yeah, like Ronnie said, if it's good enough, it makes a difference. Oh, Ronnie, you're a keeper.
That's good.
Okay. Okay, so now what we're going to be working on is the center bore over here. I'm going to rotate this part around here. So we got our center bore that we're going to kill out. So I'm going to move that spindle and turret out of the way. And that's what this MCO is doing right here. And we're going to rough out the center. Now, let me just, before I say anything, okay, this one's not doing it, so I'm not going to even bother with it. Okay, so if I just show you the geometry here, just doing simple profile. That's all we're doing here. And I want to come in there with an end mill and do a circular interpolation. Like we talked about, drilling is faster, but it's got to look good too, right? So we're just using a 12 millimeter bull nose end mill here. Levels same as usual, but with this one we're going to do a helical entry, so it's going to do a nice corkscrew inside there, leaving 0.4 millimeters on there. And so when we use this helical feature, this is your step down. So for every 360 degrees that it makes it around this part right here, it's going to go down that 0.988 millimeters. So hopefully that makes sense for you guys. So let's see what that looks like. So now we're going to kind of have to gear over to Solid Verify now that we're getting into the more milling portion of things. So okay, ooh, that was way too fast. Let me play this again, get rid of that holder. And so you can see it's doing a nice spiral, working its way down in there to rough out that. Okay, so now we need to finish off that bore. So we're going to come in there with a boring bar and show you the geometry here. Just pick that one simple line in there. You can, boy, my space mouse must be just a little off tonight. Just picking that single line geometry right here. Using that boring bar and doing a long internal. And we can see we're doing a ISO turn, and we're not doing any roughing. So I just selected finish only because we already machined out the majority of that material in there. So let's do a simulate. And since we're doing a turning, I'll do a turning simulation here. There we go. Finish pass complete. Okay, so now we're going to get into a little bit more complex, but still extremely easy. So now what I'm going to do is mill off my pads, these 4 little flats right here. So I'll come in here. Do a show. And I'm just picking this single line right here, and since my tool side is going to be left, it's going to follow along there and swipe off the top of that surface for us. So we're using a 4mm end mill here on the upper turret. I got my level set up to go down to my depth. Technology, and like I said, we're going to stay to the left. If you guys are ever curious on, where that tool is going to be, click that geometry button, and it will actually show you your tool in there. So what we did here is extended it past by 3mm. Since I didn't have line geometry, I don't need to draw it in there. I can just add that extension in right here. And just that's enough to swipe off and get us a small little pad. Then what I did is did a transform around 4th axis 6 times or 5 times, and got us this. So while this is loading up here, is this part looking a little bit easier, not so hard to tackle for you guys? Or does it still look like, oh my God, that's going to kill me?
That's what I was going to say too, Kev. Man, it's software. Play around with it on the computer screen. You're not going to break anything on the computer screen.
Yep.
And I'm still really proud of those little guide, instant help on the bottom corner of each dialog box.
Oh, yeah.
It's kind of giving you an indicator of what's going on. Exactly,
yep.
Kev.
Yep. All right. Makes it better. What makes it better is the MCO. Yeah, the machine movements. Okay. Okay. So now we're going to drill drill those small angled holes. So in here, just doing a simple in your milling side drilling right here. So grab my geometry, and we can kind of go about this 2 different ways. So I'm actually going to do this one as a transform. The next one we're going to actually do as the actual 4th axis. And for you guys that don't know what I'm talking about, if you hit this arrow down, you guys have the option to do around 4th axis. So we'll do one way, do another one another way, and you guys can see what you guys like better. So so we're going to be drilling these pads for these holes. So I got my tool set up for my 3mm hole, levels, everything set up here to cut off the tip. Technology set up. I don't know why it's set to tapping. Let's do pecking here. And so now we got our peck tapping, and let's take a peek. So do a solid verify here. And I'm going to slow this one down because I know this one goes fast. So drill, 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 drill. And I forgot to add, I did do a 4th axis transform on this also. So if we look in here, you can see we did the 6 holes on a 4-axis transform. So I only had to pick just the one geometry. So if I do a show, let me turn off that tool path for you guys here. You can see all I did is just pick one drill point inside that hole. And that's lined up with my, my Mac 1 position 2 angle right here. Okay, so now another way of going about drilling those holes around the 4th axis is right here. And like I said, this one was picked around 4th axis, so I don't need to worry about a transform. But I do have to click on all my holes. So you can kind of see right here, I had to go through and click on the holes, or come over to my feature tree and just click the holes. Now make sure your arrows are going out. We want to make sure, or it's going to think we want to drill from the bottom and work its way up. So make sure those arrows are pointing out in the correct direction for you guys. Okay, we got our 4.25 millimeter hole, drilling it that deep, and let me switch it over just to drilling here. And just a heads up for a lot of you guys, SolidCAM has released, let me get to it here, downloads, log in. So what Steve is talking about, those feature requests and enhancements, we have released SB2 HF3. So if you guys are looking for a new build, there is a new one out for you guys. All right, let's play this one through and do solid verify. Pretty much the same thing as what we just did before, just on a different position because we're using Mac 1, position 1, because those holes are straight up and down. And then this operation right here is we're basically doing the same thing except doing a chamfer. So it's just chamfering those holes. And now, if I come to this one right here, just did another save and copy, and off of this operation up here, and this drug it down to here, and we're using that same chamfer tool, kind of like Steve and I were talking about, keeping those tools sorted together to do the chamfer on those little holes on that flat pad. So if I kind of zoom in here, you can kind of see the chamfer on those flat pads. Okay. So now, oh, we got to tap those holes. Forgot. So another save and copy from up here, clicked and dragged it down. And I'll just show you guys the toolpath because we're getting a little tight on time here. So just coming in there and tapping those holes out, going around there. Okay. And now, let's see, chamfer 6 straight. Oh, no, we're right here. Okay, so now we're going to be milling out our slots. This one we're actually going to be using the simultaneous. Ben, you wrote SP3 HF3. Did I say that wrong? No, SP2 HF3. Sorry. Okay, so we're going to do SP2. Yeah, it is SP2, Ben. Hopefully I'm not getting you guys confused here. So it's SolidCAM 2017 SP2 HF3. I saw SP. Okay, yep, you're good. Okay, so this one, doing a 5-axis operation, and one, let's just open this up here. All right, so we're doing projection on this one. Want to cut on this face right here. And now with the 5-axis, we have the ability to do the transform right here under the rotate and roughing in more, using a 5 millimeter end mill and telling it to be not to be tilted, stay normal to surface. Nice and easy tool path. Let's do a simulate here. Solid verify. And get rid of that holder so you guys can see a little better. And now we have our grooves in there. Like I said, we only had to program the one, so we just get the tool path looking good on the one, and then bring it over, and we can transform it over for you guys. Okay, so we roughed and finished those, and now what we're going to do is rough and finish off our cam lobes. This one also has to be a 5-axis because we're rotating the spindle, having that live tooling come up and around. So hopefully that makes sense. Let me just simulate and I'll show you here. Oh, sorry, I got to show you the operation. And this one we're also doing a transform on. Geometry, shoe. So we have this cam lobe face right here. and projection curve. So just a simple sketch right in the center for you guys. And basically what we're doing here is I'm telling it to basically face mill off that and stay right in center. That kind of helps out for you guys in simple terms. Is basically what's going on there. Using a taper end mill, kind of like a face mill right here. And we're going to stay tilted relative to cutting direction, keeping the lead and leg angle and side tilt angle at 0 degrees. So let's see what this looks like. All right, so play this through. Just going around and working it right down to the face, doing in multiple step downs. And the multiple step downs are right here in your roughing and more under the depth cuts. So we're telling it to take it in 2 cuts with a spacing of 3 millimeters. Okay, so now we're going to transfer the part over to the right spindle. That's exactly what's going on right here. Turret's coming out. It's going to move the part out. It's going to close on the stock and clamp it. So now we are working on the right spindle. And I got a couple out of sync here. Whoops. Fat fingers here. Oh boy, I got to get working on this. We keep this right up, Stevie. We're going to be here till midnight.
Yeah, I'm telling you. No, I'm just curious what that part does, Kevin.
That part, I don't know. Florin actually made this part and tried to show every aspect of a mill turn machine as possible.
Yeah.
And there's one missing thing in here, and if I don't show it, Ronnie's going to come through the phone and strangle me. So at the end, I'll show that little feature here.
Yeah, that's a serious part. A little bit of every feature possible almost.
Yep. I think what I'm going to do is kind of skim through this so I can, there's a couple things I'm saving till the end that I want to show you guys here. Just getting everything updated here.
No, Kevin, I think, the thing about the software is just don't be afraid to try something.
Yeah.
See what works for you. And if you ever do get stuck, give us a call. We'll get you pointed north and quickly, too.
Yeah,
so,
absolutely.
I think the big thing I've always found with mill turn is just don't let it be intimidating, because it's like you've always said, it's a little bit of combination of milling and turning.
Yep.
And we can get you there and proficient with it quickly.
Yep. Okay. So now I'm going to kind of breeze through this. So I'm not going to show you the geometry. I'll show you the simulation here. So now, whoops. Maybe.
Might be a little better if we upgraded your 386 computer too, Kevin, I suppose.
Yeah, I know.
I'm just kidding.
All right, let's do solid verify here. Okay, so you can see we've transferred it over now, and it came through on this actual operation right here and just faced off the 4 tips. And basically all it did is just did a center line only and then did a transform around 4 times. Now we're going to utilize the 3D eye machining. And what I did here is the exact same thing as did a transform. So let that eye machining, work its magic and get that roughed out as much as possible for you guys. Because like I said, that getting that material out is going to help you when we come to the finishing side of things. All right, so now we have everything nice and roughed out. Obviously, we need to come back and finish it. So this operation right here is we're going to finish off those bosses. Just doing a simple, clean profile cut, selecting that bottom geometry, and just doing one finish pass, doing a transform again around fourth axis. So now we're going to move the right spindle out of the way to start working on with the lower turret. So we're going to do a finish off on the face here. So getting that up to size. Then we have a secondary face in here, which is this back face up here. Getting that right up to size also. And start the center bore using that same circular interpolation using profile. And coming back with the boring bar. So we got that finished up to size now. Now we're going to work on those angle slots. And for those of you guys that don't remember, let me just do a stock target. Here's our angled slots that are going in there. So that's basically what's going on there. Using the 5-axis operation and using that transform. And like I said, just 5-axis can be a little intimidating too, especially on something like this, but just work on the one. Once you have the one done, then we can transform it around multiple different times. So like I said, don't try to kill yourself and get all these done in one single operation. All right, so now we're going to move the lower turret out of the way for clearance. And, I'm going to drill out those bosses now. And that's a simple drilling operation. Just did a 4-axis transform. And now I'm going to finish off the inside of those holes. Finish keyway right. What am I missing here? Oh, it's finishing off the 2. I'm sorry. So these ones that have a keyway going through there, just getting those to the correct size. Now we're going to do the internal threads using the thread milling operation. I think that's going a little fast. Slow it down here. Oh, I'm sorry. That is the thread relief at the bottom. So if I go down there, we can see it cutting, just doing a thread relief at the very, very bottom there. And just pick the single line geometry at the bottom of that relief in there and doing a transform one time to do the bottom. So now we're going to use that same tool and do the thread relief for the outside. And now we're going to use that same tool again here and do where the keyway cutters are going. So right here and right here. And use that same tool again. And you guys remember those, there were some slots. So we have one slot right here. Do save and copy and switch my levels up because I have one right underneath it. Oops. So there we go. We got the one right underneath there. We're good. And this boss should be done now. The only thing we have left is the thread milling on these two, internal and external. So we'll do the internal threads first. And like I said, just do the one and do a transform. Make the life easier for you guys. That way you don't have to add an additional coordinate system in there also. External threads. Okay, it looks good. And I'm just kind of looking here, make sure my, I think I would go a little bit deeper with my thread relief here so I can come back and change that for that thread mill. But okay, so using a spot drill and just kind of chamfering the threads, chamfering the other two bosses, inside and outside, like I said, just do the one and then transform it over. Okay, now we're going to move the spindle out of the way for clearance. We're going to chamfer the grooves on these front faces right here. So just doing a nice light chamfer on there. Just using the one is geometry, and we're actually doing a rotate on this one. As a transform instead of fourth axis. And now what's going on here is, if I go down to here, we are moving the right spindle out, we're unclamping it, and the parts catcher is catching the part. Now, let me turn off this toolpath here. Ronnie, what am I forgetting to tell you about? And I know a couple of the other guys were asking about it. Yep, you got it. Broaching. Okay, so we got our part with broaching right here. So easy enough. So what we're going to do here is I'm going to look for, is this the one? So my Mach 3 position 5. Yep, Mach 3 position 5 is what I want to do. So I'm just going to right click on this, do add milling operation here. And we are going to do a toolbox cycle. So now, I was doing this part earlier, and I couldn't figure out, I'll show you exactly what I was doing. So I was coming in here, and what you want to pick is, man, my space ball is just, you want to pick, if I can get to it, basically this line. So I'm grabbing, dang it. I had my auto constant turned on. Let me delete that. Yes. Turn off my tangent propagation here. Zoom in here. Got my single line. Go to hit the green check mark, and I get this error. I'm like, man, what? Then I tried clicking on several other geometry. Inside the toolbox cycle, I completely forgot it's set to spiral open slot. Obviously, that's not going to work for us. So we need to go over to the broaching. So we go ahead and click on broaching. Now we can grab that geometry. Tangent propagation, turn that off here. And there we go. Okay. So I set up a broach tool already. And as soon as it comes up here, I just got to find it in my list. Oop, I forgot to do something. I need to switch to my lower turret here. Tool, select. And here's my broach. So my slot width is 3 millimeter, as you can see down here. I got a 3 millimeter broach. Got everything kind of set up. Hit the green check mark. That's funny, my broach is showing off center now. It was showing correct. All right, we can look at that later here. Levels. Let me set up how deep I need to go here. So I'm going to broach down to right there. And we'll just go a minus 0.1 millimeter past. Technology, we'll do right. And, you know, if we want an extension out or do we want to take it one cut, we're doing it in 1 millimeter step over right now. Let's just see what we got. And what am I missing here? My height levels, upper level, depth. There we go. Now, go ahead and do a solid verify here. I got my tool going the wrong way here. Could have sworn I had this broach all set up for you guys. What am I missing here? I see what I got going on. Okay, so I was telling it to broach on this side, but if you guys look, my coordinate system is over here. I grabbed the wrong geometry. Come on, Steve, you're supposed to catch that for me.
Yes, the sales guy kind of missed on that one, Kevin.
Hey, I'm just happy you finally got a smartphone.
I'm telling you what, I'm probably learning more than the rest of the class, actually.
All right, so I gotta go.
I like that about the software too. It will warn you if you're doing something wrong.
Yep.
Give you a little
absolutely. That is for sure. Okay. Now, there, that's looking a little better. All right, so let's do a solid verify here. And we're coming in there and broaching that out. Does that kind of help, Ronnie? You're welcome. Okay, so on that one, now obviously what I can do is I can do a save and copy, and all I have to do is switch out my geometry to this one, and then we can do a 4-axis transform. We're running a little late on time here, so I want to show you a couple other things here. Okay, so we got our broaching in there. I didn't want Ronnie to be mad at me, so I had to get that one in there. Okay, so we did talk about channel synchronization. Now, like I said, on this specific machine, it's not set up for it. So what I'm going to kind of do is update it and remove some things. So you can see I have a couple different setups. One is when we're on the right spindle, and then we have one for the left spindle, and a couple other ones. So what I'm going to do is go through and delete these setups real quick. And delete that setup too. I know you're never mad, Ronnie. I like to give you a hard time though. All right, and I know I have setup one up here. So I just want one setup. And that's pretty much how your mill turn machines are always going to be. You only need one setup and that's it. You don't need multiple setups like we did with this part. So now, once this is done being removed, okay. And let me just do edit and in stock. That looks good. Okay. Okay, so now what I'm going to do is I want to find out what tools I can be doing at the same time. So I can be in the left spindle machining and I can have something going in the right spindle machining. That's a lot going on. So what we have for you guys is what's called channel synchronization. And if I go to your SolidCAM turning, what it's going to do is it's going to look at your tools and what operations and stuff like that, and it's going to combine them so you can be working on the left spindle upper turret and the right spindle and the lower turret doing things at the exact same time, so we're not wasting time doing multiple things just on the left side and then it moves over to the right side. So it's very easy to do. Just click the channel synchronization, and anything over here on the that kind of overlaps is what we're going to be able to do at the same time. So obviously the balanced roughing, we're going to be doing at the same time, the upper and lower. But now when we're doing the finish, the 4 bosses, we'll also be able to rough the left face at the same time. Same thing down here with mill finish. On the, let me try to expand this out a little bit here. Yeah, drag this out. No. So over here, we're milling the finish face on the right side, but I'm also able to rough out the front groove. So all these right here, I'm able to do at the exact same time as the left spindle will be doing operations at the exact same time as the right spindle. Now it's going to show you, you guys can click and manually drag these around as you wish, but if you guys do get a red, if it's red, that means there's interference. There's something that's going to interfere with each other. So keep that in mind. And if you guys want a real in-depth on how the channel synchronization works, there's 2 videos on the in the SolidCAM University channel that will go over that with a T for you guys. So I'm not going to cover too much here just because we're going a little late as is, but it's as easy as just clicking that channel synchronization and everything gets done for you automatically. And just make sure you hit the save button. Yep.
Quick question. You know, we've kept channel sync as an option. Is that machine dependent, or is that more if you want that flexibility or capability in your software?
More or less, well, kind of both. It's definitely machine dependent, because if you don't have upper turret and a lower turret, there's no point.
Sure.
There's nothing to sync up. So it's just to optimize that toolpath for you guys. So you guys don't have to come through, let me exit out here, and click and drag all this stuff around to try to figure out what it's going to look like after you have 2 things going on right here. So this is going to check the interference, make sure that upper turret, you know, if the spindle's spinning, obviously we can't be doing a milling operation at the same time. So it's going to take out that guesswork for you guys and really make things very easy in that sense of things. So.
Good, but one of those software options that can pay for itself really quickly.
Yes.
Correct?
Yes.
Okay.
Absolutely. Cool. Especially if you pile up one of these machines, they're not cheap to fix.
Yep. Good deal.
Any questions, guys, though? That kind of wraps up mill turn. Is there anything that I missed with mill turn that you guys wanted to see? We kind of started off with some simpler parts and kind of worked our way up to some crazy looking parts. But let's see, can we see the combine? Okay, so yeah, I can show you the combine synchronization right now. What it's going to do is, since I don't have that machine sim set up for this machine right now, we're not going to see everything correct just because the solid verify is the only thing that we can base it off of right now. So we can't show a left part and a right part at the exact same time. So the fixtures kind of bounce around. We're going to show crashing. So this is where the area, and Steve, when you purchase mill turn with channel synchronization, does that come with the machine sim, or is that an add-on?
No, that would be an add-on.
Okay.
Kev, yeah.
So if you guys are doing channel synchronization, that is a kind of a, I would say, a must-have to have the machine sim. But like I said, unfortunately, I don't have one for this specific machine, so won't be able to show you that one. But
yeah, we can definitely. All we need is the models of your machine, and we can put together a full-on machine sim for really any machine out there, Kev.
Absolutely. Yep. Even, I had one that Greg was showing at SolidWorks World. Pretty much a kind of a Swiss turn machine is basically what it was. Mm-hmm. Was it Quick Tech? And yep. I know Greg's hiding in here. Greg, is he on mute? Mm-hmm. Come on, Greg, come out.
Well, you can't out me. I'm lurking in the background.
Greg, was that a Quick Tech machine?
Yeah, that was the Quick Tech machine.
Okay.
And so, a very complex machine. I think you should show it off in next week's class after Sydney's done with his presentation.
Yeah, absolutely. Definitely show it off for you guys and show you how cool it is. And like I said, getting closer to that Swiss screw machine. So we hear a lot of positive things coming with the Swiss. So should be coming for you guys very soon. Well, maybe soon, not very soon. Steve's going to have a bunch of calls tomorrow and saying, "Why'd you say it's coming right now?"
No doubt.
But all right, guys. Well, that kind of wraps it up for the night class. I apologize for going long, but I can't thank you guys enough for sitting through the class and me being able to show you guys everything that I know about the mill turn side of things. So like I said, next week we are going to be covering a sneak peek into 2018. And then after that, for you guys' request, and my stupidity, I forgot to cover the AFRM, which is the automatic feature recognition. So we'll be doing pocket recognition, drill recognition, chamfer recognition, and hole wizard. In hole wizard, we're actually going to dive really deep, really deep. We're going to kind of go through, show you guys how to modify that, how to, so inside there, you guys will be able to do a spot drill tap. It's going to automatically pick those tools, but what you guys can do is go in there and modify it. So let's say you guys are using a roll form tap, which we need to use a larger drill bit for. You guys can modify it up so it leaves a chamfer on there. So that'll be really cool to show you guys. So can't wait to do that class too. So a lot of great stuff coming up for you guys. But Steve, you got anything else that I forgot?
Nope, I don't think so, except to thank people for the time. Keep the ideas coming. We want to make these as valuable as possible for you.
Yes, absolutely. And yeah, love seeing the comments for you guys. And if I do give you a hard time, it's only just because I like you. So, Rodney, you can't leave my classes anytime soon. It's too nice having you here. But all right, guys, you guys have a wonderful night, and we'll look forward to talking to you guys next week, and we'll get Sydney out of bed at bright and early for you guys. So,
yeah, no doubt.
All right, guys, have a wonderful night.
All right,
see you guys.
See you, everyone. Bye.